So let us start a new chapter today, that is relations and functions. This is the second chapter of your class 11, right? So we will do every example, every question that is given in the NCERT book. So let us start with the first thing here. Do not worry about what is relation, what is function as of now. Let us learn a few terms, then we will proceed to these terms. Now let us learn very simple term, ordered pair. Ordered pair. Now in mathematics, an ordered pair is a pair of objects, right? So it is a pair of objects. Let us say if I write A comma B, so it is pair of these two objects, right? Now why is it ordered pair? Because the order in which this pair is written is significant in it. So what I mean is an ordered pair is a pair of objects and the order in which the objects are written is significant. What do I mean by that? That if I write, and this is how I write the ordered pair. Now some of the students may think that we used this kind of bracket while writing the open intervals in the last chapter, right? You remember? But for ordered pairs also we use this bracket, right? So how will you differentiate between the two? It will depend on the context, right? So it will be clear from the question or context of the article itself that it is being used for ordered pair. So now when I write A comma B, where A is my first entry, right? This is what? This is first entry. And B is second entry, right? In this ordered pair. And if I write, let us say B comma A, where B becomes my first entry and this is the second entry in this ordered pair. Now these two ordered pairs are different, right? They convey different meanings, right? These two ordered pairs, A comma B and B comma A, are different from each other until and unless A is equal to B. Until and unless A is equal to B, right? This is an exception, because if I write 1 comma 1, how can it be different from 1 comma 1? But until and unless A and B are equal, or if let me say it in other terms, if A and B are distinct, then A comma B, this ordered pair, and B comma A, this ordered pair, these are different pairs. That is the significance of ordered pairs. So let us say if I write 1 comma 2 and 2 comma 1, right? These are different ordered pairs, right? They convey entirely different meanings. And if I write x comma 1 and 2 comma 1, now these pairs, if I say that for x comma 1 and 2 comma 1 to be equal to each other, it should happen that x is equal to 2, otherwise they cannot be equal. So for them to be equal, the first entry of both these ordered pairs should be equal and second entry of both these pairs should be equal. So what can I say collectively is that their corresponding elements should be equal, or you should say must be equal, for two ordered pairs to be equal. So if I tell you that x comma y, this ordered pair, is equal to this ordered pair, let us say, so you can clearly say that x should be equal to 3 and y should be equal to 5 for these ordered pairs, to be equal. Similarly, a lot of questions can be formed based on this simple fact. For example, you can write x plus 1, y minus 5 equal to, let us say I write 1 here and 7 here. So for them to be equal, of course x plus 1, that is the first entry of this ordered pair, should be equal to the first entry of this ordered pair. So the corresponding elements should be equal, which means x should be equal to 0. And this element here, y minus 5, should be equal to 7. Y minus 5 equals 7, which will mean y should be equal to 12. So these kind of questions can be formed on the basis of this ordered pair, right? Now if I collect all the ordered pairs, whose first entry is from, let us say, set A, and whose second entry is from set B. What I mean is, I am collecting all ordered pairs whose first entry is from set A and second entry is from set B. For example, let us say I have got a set A which has got elements 1, 2, 3, and there is this set B which has got elements 4, 5. Now if I collect all ordered pairs whose first entry is from set A, so what can be the one of the ordered pairs? First entry if I take as 1, second entry I take 4, then this will be one of the ordered pairs that I am going to collect. What will be the second ordered pair or another ordered pair? If I say take 1 from here and 5 from here, it will give me another ordered pair of which first entry is from set A and second entry is from set B. What can be other ordered pairs so that the first entry is from set A and second entry is from set B? So it can be 2, 4, 2, 5, 3, 4, right? And 3, 5. So these can be the ordered pairs such that their first entry is from this set A and second entry is from this set B. And if I form a set of such objects, right, or such ordered pairs, now this set is known as A cross B. So this has got a name, Cartesian product. Cartesian product, right? It is Cartesian product of two sets A and B, right? So what is Cartesian product of two sets A and B? It is a set, right? It is a set of all the ordered pairs where first entry is from this set and second entry is from this set. What I mean is, if let us say some student asks me, sir, what will be B cross A then? So I will say, now the first entry should be from set B and second entry should be from set A, and set of all such ordered pairs will be B cross A, or Cartesian product of set B into set A, right? So A and B, B and A, these are two different things, right? We are talking about ordered pairs here. So B cross A will have this set. Now this is a set of all the ordered pairs whose first entry is from set B. So first entry 4, second entry will be from set A. That is, it can be 1, it can be 2, it can be 3. Now if I take first entry from set B as 5, now the second entry should be from set A, so it can be 1, it can be 2, or it can be 3. Now this collection of ordered pairs where the first entry is from set B and second entry is from set A is called B cross A. And as you can notice, A cross B and B cross A are entirely different, right? They have different elements in them or different ordered pairs in them. That is why we defined ordered pairs, right? So 1, 4 is different from 4, 1. they have different meanings. So as you can see, there is nothing in common in these two sets, A cross B and B cross A. These two sets are disjoint, right? Okay. So let us write a formal definition for your class 11th. Given sets A and B as non-empty sets, non-empty sets. You mean like set A as well as set B should have at least one element, right? It should not have, it should not be an empty set or a null set, right? We have studied about it. What is a null set? Which doesn't have any element in it. But if it has got, let us say, even one element, that is a non-empty set. So we are considering these two non-empty sets. Then A cross B is defined as set of ordered pairs of elements from set A and set B. What does it mean? That set A has got certain elements, set B has got certain element. So their Cartesian product, or Cartesian product of A and B, is set of ordered pairs of elements from A and B, right? So let us say, if I write it in set builder form, A cross B is equal to A comma B such that A belongs to A. Now this is my first entry and it should belong to this set here, the first one, and this B belongs to B. So this is how I write A cross B in set builder form. Alright, I hope you have got the idea of the Cartesian product of sets. Now let us discuss a little more about Cartesian product of sets A and B. For example, let us say you have got, let us say I take three colors, red, blue and white. Okay, and I take, and this is set A, and then in set B I have got certain objects, like it may be a shirt, it may be a trouser, or let us say there is a bag. Okay, so if I do A cross B, what kind of ordered pairs will be there? Ordered pairs that it will have will be red shirt, blue shirt, right, white shirt. Now how did I form these ordered pairs? I just took first element from set A, the first entry of this ordered pairs from set A. So I took these first entries from set A and this second entry from set B. And what else can I take? I can take first entry as blue and then second entry as shirt, I can take blue shirt. I've already taken, right? So I've taken the first entry as red and second entry as shirt already. So let me change this entry as, I'll take now red from the first set and then I'll take trouser now, right? So you have to make all the ordered pairs that are possible. Okay, let me do it a little neatly here. So you should not forget any element, right? For that, what you can do is, let us take red in the first place and then see what can be there in the second place. So trouser and bag can be there. So let us write trouser here. Let us write bag here. So these are the ordered pairs with first entry as red. Now with first entry as blue, I can have shirt here, trouser here, and bag here. Right? With first entry as white, I can have shirt, trouser, or bag. Right? So set of all these ordered pairs will be A cross B. Okay, so this is how we look at A cross B or Cartesian product of two sets. Now if let us say I take all real numbers, okay, in set A, let us say there are all real numbers, or we know how to denote set of real numbers. Let us denote it by capital R. So this is a set of all real numbers, and we know how to write real numbers. We do not write real numbers in these braces. You remember, we write real numbers like this, minus infinity to infinity. Okay, so if I take set of all real numbers as my first set, and then I want the Cartesian product of this set with R again. So what I'm trying to do here is, this is real number line, right? And this is my x-axis. On y-axis also you have all the real numbers. So if I take Cartesian product of R into R, which means at the first entry, this is a set of all the ordered pairs such that the first entry here is a real number from this set, right? And second entry is also from a real number, right? First entry is a real number, second entry is also real number. So what does it look like? It looks like the Cartesian coordinates. Cartesian coordinates. You remember? Now if let us say the first entry of ordered pair and the second entry of ordered pair is a real number, right? At both these places we have got real numbers, then it will be nothing but Cartesian coordinate. Cartesian coordinate, and where this first coordinate is the x coordinate and second coordinate is the y coordinate, right? Remember, this is how we write it. Okay, so this Cartesian product represents the set of all coordinates in two-dimensional Cartesian coordinate system. It represents all the points in Cartesian coordinate system, R cross R. If let us say we are not talking about real numbers and we are talking about any other set of numbers, like A is a set of A1, A2, A3, and B is a set of numbers B1, B2, right? Now these are not the coordinates, right? Because I have not said that these are a set of real numbers, so I can represent them as a grid of rows and columns. Let us represent this as our rows and this as our columns. Now how can I form these ordered pairs? I want the first element. Now I want to write A cross B. Okay, so I want the first element from A and second element from B, right? So I want the first element from this row and second element from this column. And how many combinations, how many such combinations can I form? I have to see. So if the first I can form, I take A1 from this row and B1 from this column. So A1, B1, right? Now A2 from this row and B1 from this column. A2, B1, A3, B1. Now A1, B2, Why? Because A1 from this row and B2 from this column. So A2, B2, A3, B3. Right? Now, if I represent them by, let us say, these points, now this is not the Cartesian coordinate system. This is general grid. So you can see that these points are at different places, or they represent something different from each other, right? So A1, B1 and B1, A1 are two different things. All right. Now this is one of the things that I wanted to say. Another thing is that if you want to count these objects, or if you want to count these ordered pairs, how many will be these? You see, in this row I have got 3 elements, and in these right these, how many are these? These are 3. Now this is I have represented this as a column, but these are number of rows: 1, 2, 3, right? 3 rows. And how many columns are there? 1, 2. So if I multiply number of rows with number of columns, that will give me total number of ordered pairs, right? This is something which is very, very simple. Any grid you can write. For example, let us write it like this. How many number of rows are there? There are 2 rows. How many columns are there? 1, 2, 3, 4 columns are there. So how many number of ordered pairs can be formed? 2 into 4, that is 8. Right? This is something. How many of if you want to count all these crosses, how many are these? These are 8. Right? So if I want number of elements in A cross B, how can I find it? Number of elements in A cross B, or Cartesian product of A and B, will be equal to number of elements in A into number of elements in B. Right? If, let us say, set A has got 3 elements and set B has got 3 elements, then what will this set, which is a product, Cartesian product of A and B, what will be the number of elements in that set? It will be equal to 9. 3 into 3. Okay, you can take a very simple example that will give you an idea about it. You know, 52 cards are there. 52 playing cards are there in a deck of cards, right? You remember that? We did such questions in class 10th probability involving 52 playing cards, right? What kind of cards are they? There are numbered cards, there are face cards, right? Let me draw it for you. So if I write all the ranks here, let us say, what are these cards? There are numbered cards like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there is Jack, Queen and King. Now there is no card as numbered 1, right? We have got aces. So let me write it here. How many are these? There are these 4 cards that are written as Jack, Queen, King and Ace, and these are numbered cards, or you may write it as 1 here, even that will give the same result. There are 13 cards, right, of different ranks. And what are the suits that are there? So let me draw with the color. I have got hearts, then there is diamond in red color, right? What else? Then there is this clubs in black color, and then there is this spades. again in black color. So you must be comfortable with the idea of playing cards, because we have done this in probability class 10th also. I hope the diagrams are visible to you. These are spades, clubs, diamonds. Diamonds and hearts are in red colors. Right? Now, if I pick something from here, from the ranks, now we have got a king here. Okay? So we have got 4 kings in playing cards. King of hearts, king of diamonds, king of clubs, and king of spades. So if I want to write, let us say this is set A, this is set B, right? Set A is set of all the ranks, set B is set of the suits. Okay, now if I want to write A cross B, let us say, so I'll write one of the elements will be 2 of hearts. Okay, one of the elements of this set will be 2 of hearts. All right, so this is how these will be formed, these elements of this set A cross B. And if I ask you what will be the number of elements in this set A cross B, number of elements in this set will be equal to 52. We know there are 52 playing cards, and every rank here, for example this 3, will have 4 cards. How? 3 of hearts, 3 of diamonds, 3 of clubs, and 3 of spades. Similarly, this 9 will have number 9, there will be 4 such cards. Number 1, 9 of hearts will be there, 9 of diamonds will be there, 9 of clubs will be there, 9 of spades will be there. So in that way, there are these 13 cards, and corresponding to each rank, there are 4 cards. I hope you got the idea. So how many ranks are there? There are 13 ranks. And how many suits are there? There are 4 suits. So I'll multiply them to get the total number of cards. I hope you have got the idea that there is set A having elements, number of elements in set A is P, number of elements in set B is Q, then number of elements in set A cross B is equal to PQ, right? Product of P and Q. Okay, and there is another name for this number of elements of set A is equal to P. So there is another thing, there is another phrase that we can use for this, cardinality. So what is cardinality of set A? It is P, and it means the number of elements contained in it. So what is cardinality of set B? It is Q. So what is cardinality of Cartesian product of A and B? It is the product of cardinalities of set A and set B. Now there should be 1 or 2 things that you should take care of. That we talked about these 2 non-empty sets, right? So if, let us say, what will happen if one of these sets is empty? If one of these is empty, what will happen? Right? Then this resulting set will also be empty. A cross B will also be empty, right? Because I need to pick one element from the first set and second element from the second set to make one ordered pair, right? If one of the sets is empty, I will not be able to form ordered pairs. So this A cross B will also be empty if one of these sets is empty, right? Number 1. So we can write it as if A or B is empty, then A cross B will also be empty. Another thing that we should notice, if one of them is, let us say, has got infinite number of elements, one of them is infinite set, right? And of course the second one, of course the second set, and the second set is non-empty, right? Then what will happen is A cross B will also be an infinite set, right? If one of these sets, let us say set A is infinite set and set B has got only one element, let us say. So when I select the first element from set A, I'll be able to select infinite elements, and corresponding to them, the second element will be, let us say, I've got set A as set of natural numbers 1, 2, 3, 4, 5, and so on. We know that this is an infinite set, and for example set B has got only, let us say, one element, that is 4. Okay, so how many elements will be there in A cross B? Let us try and write some of the elements. So if I take first element from here, because I know that I need to write ordered pair where first entry should be from set A and second entry should be from set B when I'm writing A cross B. So 1 from here and 4 from second set, right? 1 from the first set, that is set A, and 4 from B. Of course I have written it again. 2 from first set and 4 from B. 3 from first set, 4 from B. 4 from first and 4 from B. I hope you have got the idea that we can keep on writing such ordered pairs, right? They are infinite in numbers because I can select my first element in infinite number of ways, right? Of course the second element will remain the same for all of these. However, the total number of elements of this set will be infinite or infinity. Okay, and one more thing, like we said ordered pairs, we talked about ordered pairs, we can also talk about ordered triplets. Ordered triplets, for example, if we take Cartesian product of three sets, okay, A, B and C, and as a result we get this triplet A, B, C such that A belongs to A, B belongs to B and C belongs to C. Now this is known as ordered triplet, and we can take like we can take this Cartesian product in the same sets also, for example A cross A cross A. So it will give me, let us say, triplet A comma B comma C. Then I'll write A belongs A, B and C, these belongs to set A, right? So these are ordered triplets. We can have n number of sets in this Cartesian product. We can take Cartesian product of n number of sets, but for this exercise this much is sufficient. So we can start the examples from here. So let us start the examples. Example 1 says, if this ordered pair is equal to this ordered pair, then find the values of x and y. Now for two ordered pairs to be equal, for two ordered pairs to be equal, their corresponding entries should be equal. Entries or elements or you can say, right, coordinates if there are real numbers, right? Their corresponding entries should be equal. For example, in this question here, this first entry should be equal to this first entry. So x plus 1 has to be equal to 3, y minus 2 has to be equal to 1 for these two ordered pairs to be same. So this will give me x equal to 2 and this will give me y equal to 3. So this is what we had to find out. Now in this I need to take Cartesian products of these two sets. First is P into Q. So it will give me, now when I take Cartesian products of P and Q, I need to take care that first element comes from, or the first entry of the ordered pair comes from this first set here, and second entry comes from this. So how many such ordered pairs can I form? And I'll have to write it here. So the first entry, if I take A, second entry will be R, that is this. First entry, if I take B, second entry R. First entry C, second entry R. So these are the only possible ordered pairs I have written. So when I write a set of these ordered pairs, that will give me P into Q, P and Cartesian product of P and Q. And I am also required to find Cartesian product of Q and P. Now the first entry has to come from this set, which is R. It has got only one element, and second entry will be from this set P. So R A, R B, R C. These are the ordered pairs that will form the elements of this set Q cross P. Now, are these two products equal? No. Why? Because this ordered pair A comma R is different from R comma A, because they have got different elements, right? Why aren't this product P into Q and Q into P unequal? Because, right, these products are unequal because their elements are different. They have got different elements, and for two sets to be equal, they should have exactly the same elements. Okay, I think this much is enough for this lecture.